Hey guys, so this is another Toolbox talk. We're continuing in our discussion of ratchets. Last time we talked about the cylinders, we talked about accumulators, and a couple of things you should have as a takeaway from that is everything's governed by flow. Flow makes things happen quicker, stronger, better, okay? So airflow is highly important. That applies to 90-degree bends, that applies to port size, it applies to everything and not so much more. We're going to get into the valve control box today, the push button control box, also known as a trigger box. But you don't want to call it that when you're shipping it. It's a push button control box. So the takeaways from that: lubricate your cylinders. Seals only function with lubrication, as with any seals. They don't want to be worn out, okay? We don't care what inert gas you use. If you want to work harder, hey, carry a giant nitrogen bottle around, but you still got to lube your cylinders. The airflow in and out of the accumulator should have a valve on it, because you can fill your accumulator separate of triggering the valves. That way, if you fuck up or drop the thing or have a button that's not working, anyway, you know that ahead of time, because the system in the control box isn't live. There's no high force air pressure behind it. So everything works step at a time. It's a way of checks and balances so you don't fuck something up and hurt somebody. Okay? So those are your takeaways so far. The support under your rod end. Anyway, all of this we've talked about. So these are takeaways you should have. You should know how to calculate the force in your cylinders based on the air pressure. You should know the volume to be able to size your accumulator based on the formulas we had up last week. Because it isn't going to do you any good to have 11 liters when you need 20. You're going to wonder why nothing works right. So these are all important things that you need to mathematically calculate and figure out. Flow, on the other hand, is something that you can calculate and learn. It just requires a lot of math, and you got to read on pneumatic control systems and valves and etc. So today we're going to get into trigger boxes. I've got a little blurb I'll intercut on this on mine. So here's just a sample of how we've arranged our boxes. They're kind of over the top in one direction only. Air comes in from the left side and flows to the right side. You have an additional gauge besides what's on your accumulator. You have powering and arming switches. When it's armed, the button is able to function. You have your first electric valve. In this case, we only use high flow direct action valves. Here is a manual safety. If it is open, it is in direction of flow. If it is closed, it is against the flow. This prevents that valve from working. As we talked about in our lecture, this would be your ultimate going hot. It requires a person to intervene and open that valve for the air to go out of this fitting to the cylinder. The only T in this box, the only change of direction in the airflow is in the exhaust, where it comes down to the exhaust valve. Okay? Now, the exhaust valve exhausts the air out of the cylinder. If you need to hold someone in the air, you would close that off, hence another valve. Open or close. Closed against, open in direction. And a metering valve, which allows the flow to be sped up or slowed down according to requirements. And the last step is a silencer, because it's loud with this much airflow. This would be your battery situation, which powers these two valves. And this would be your charger, which charges the system so that you never run out of battery power. And I have sized the charger so that it can run this system if you have totally battery failure. Okay? So that's the setup on mine. And up top, we have also a timer area to time on, time out, and we have additional outputs, but that's just because I wanted to do all the things to control interaction with humans. That way, it's not a mistake or an oopsie. Okay, so that's what you're gonna see, and we're gonna talk about this now. But all a trigger box is a way of bringing air pressure in, and at the push of a button, sending that air pressure, directional flow, as all pneumatic valves do, directional flow, sending to your cylinder to do work. That's it. Okay, so in its simplest form, you push a button, the cylinder pulls back, period. The air is held in your accumulator. it goes to your control box, to your trigger box. Your trigger box holds that 10 bar or 100 PSI or 150 PSI. Behind that valve, you push that button, that valve opens. It sends air to this to do work. You come off of that button, it exhausts that air pressure so there's no more force pulling, and it can stroke out again. So if someone was falling, we do this a lot to pick people up and set them down, depending on the geometry. But if it was vertical, you just pick them up, you get off the button, they come back down. There will always be some form of flow control on the exhaust so that you can do this down motion, in other words, stroking the cylinder out, slowly or fast, or if you want a way to shut it down completely so that it can go up, and no matter what the valve does, it still holds up in the air. Okay? So that's a trigger box. Simple, in theory. The problem gets to be with the numbers of different kinds of pneumatic valves that are out there, with the flows, again, with the speed with which they work, and with the pressures. So, in a control box, we're working with what I consider to be high pressure. It's low overall standards. We're talking, 10 bar, 12 bar, 15 bar. 200 pounds, 300 PSI max, usually. But in the world of valves, that's a fair amount of pressure. Most valves are working at 10 bar, 150 PSI. So there's several kinds of valves and several styles of valves. You count the work they perform and the ports that are on them by how they work. So I use 2-port, 2-directional valves. It either flows air one way or it shuts off air the other way. It simply works. Boom. It opens, it closes. That's it. They make 3/2 valves where it will open, send air one way, and then when a valve changes direction, it will exhaust the air back out, okay? 3-2 valves, okay? So those are the two common types in our trigger boxes. Most people, 99% of the people out there use 3-2. It's one valve. It's some of the high-end ones flow about half of, or less than half of what mine do, but they're the best you can get because they're piloted. They do the task of 2 valves. They exhaust as well as activate for flow. So you can hit a button, one port opens, it sends air to the cylinder. You get off the button, the other port is now opened and it can exhaust the cylinder. That happens in one valve. Okay, so continuing down descriptions and definitions, we also have direct acting and piloted valves. Now, most higher pressure valves, are piloted. That means it uses a small solenoid because solenoids don't generate that much force. It's a magnet current that pulls a valve open. Most valves are piloted if they're using higher pressure. So a little valve opens your big valve. So in your trigger box, you would have, for say, most of these 3-2 valves, an electric solenoid powered by 12 or 24 volt current. Common for us because we use them where there's no plug-ins available, and you don't want to always have to plug your RAM in if you're out in a field or next to a river somewhere or in the forest or on a building. You don't want to have a generator running mains power. So whether that's 120, 220, whatever your power is. So we discount those and we use battery operated 12 or 24 volt. What that means is that with that current, most valves that handle over 10 bar, so known as high pressure valves, cannot function, cannot open the valve that's required because of the pressure. The harder you push air against something, the more it stays closed. It's harder to change it to open, so you need more power to move that valve off of its seat. Now there's a million kinds of valves. Some pull a valve off a seat, some move a flap around, butterfly valves. For us, we generally use the valve seat version. Most people. I'll get into the differences with what I do. So you need a way that doesn't use an exorbitant amount of power to open that valve. So they use, it's called a pilot. It's a small orifice that directs air pressure to a smaller valve that causes the bigger valve to open. Now, this could be a diaphragm. There's all these valves. So if you want to look at them and learn about them, please do, because I have, and it's always entertaining. I've done it a lot, and I've arrived at what I build for a reason. Anyway, so now you have a valve that generally can do two tasks. It can open, send air to your cylinder, or close and exhaust your cylinder. And it's a piloted valve. There's also direct acting valves. They tend to be much larger and they will flow, but as you get up in higher pressure, they get exponentially more expensive. They flow far higher quantities of air, but they require more power. Additionally, because of the way we use them, you don't get many direct acting 3-2 valves, in other words, dual direction valves. So what you have is a pilot system that's usually a low pressure air supply that will control that valve on a piloted valve, which implies in your box you're going to have a small reservoir tank that has a regulator on it to regulate a low pressure air, because if you only need 70 psi to move the pilot valve and you've got 200 psi in your accumulator, it's not going to work. So what you have to do is have a small reservoir that is regulated down in pressure, or a line that comes off of your accumulator feed that will give you your low pressure to be able to activate your valve. This brings in several areas of failure. One, leaks. All the hoses, regulators, all the bullshit that goes with that causes problems. I've seen it. There's a million people out there. They've done these boxes this way on and off forever, and it's not very beneficial. You end up with leaks and they don't work. You have all the battery power in the world, the valves want to work, but you push the button, nothing happens, and that's because you've lost the air pressure to function on the small solenoid that activates the valve. Okay, so 3-2 valves have that problem. 3-2 valves also do not flow. As we mentioned before, valves are measured in CV, constant velocity, and they'll measure how much volume of air over a set time it'll flow. It's not a useful number for us, but it's a way of comparing apples to apples when you look at a valve. So if you look at a CV volume on a 3-2, the biggest 3-2 valves, which are piloted, can flow around 8, have a CV value of 8, okay? The bigger valves I use have a CV value of 14, okay? To put that in perspective, that's almost twice as much, okay? So what you're gonna do is you're gonna sacrifice flow and efficiency. They'll function. The reason most stunt guys use them that way, and most stunt guys that have them built that way, is because the valves are cheaper. You don't have to do your homework, you don't have to do your math. You just get one valve, does it, thank you. You put one in there, then you put a regulator in there, then you put a this, then you put a that. And you end up with a very complicated plumbing nightmare box. And on top of that, I'll just say this quickly, people put the reservoirs, the accumulators, in the boxes. Now, there's no possible human way to put an 11-liter bottle in a box and still function with the directions of the valves without having a massive array. I've counted in some people's boxes 10 or more 90-degree and 180-degree bends to be able to plumb this convoluted pile of shit shoved in a box. Makes no sense. Air should simply go in and go out. The straighter flows, the better flow, okay? Even if you have smaller ports, and as you get bigger in ports, then you want it even straighter because you get more results. And remember, like we saw with the formula on area on the piston face, it's not a linear function. So in other words, our piston face on a 4-inch cylinder here was 7 psi on the rod side and 12 psi on the 7 pounds of force from 100 psi on the rod side and 12 pounds of force on the face side. That 1-inch rod in the area calculations that's on one side made almost a 50% difference, okay? Almost a 50% difference in the power this cylinder could function. So using that, think of that in your mind. That's a rod this big around over the distance. So now think of it a port. If you go from a 1/2 inch port to a 3/4 inch port to a 1 inch port to a 2 inch port, it's exponential how much more air you can flow per unit time. Exponential. It's not a linear, it jumps by the square and the triple and the quadruple. It becomes massive, okay? So this is why I avoid piloted valves, which have flow restrictions. You're flowing things in bends through inside the valve because of the way the valve system's set up. If you look at the air diagrams on them, if you know how to read them, learn how to read them, then you'll understand this. Just put it this way, they aren't as efficient, even kinda, sorta. So that's left with 2-2 valves. It means basically it opens, it flows, it closes. What I do is I run 2 valves. One for flow into the cylinder, one for exhaust out of the cylinder. And they're set up so that when you push the button, the exhaust closes and it sends air to the cylinder. When you're off the button, the exhaust is open, the input side closes, and you can exhaust air. It is the better way to do things. Inherently, it has issues. It's twice the plumbing, it's twice the electronics, it's twice the wiring, it's twice everything, because now you have 2 valves. But you can get much better action, much quicker action, and much more flow out of 2-2 valves. Now, for high pressure, they tend to still make 2-2 valves pilot activated. You have to go, there's only a few companies in the world that make large high pressure valves for industry that are direct acting. I use only direct acting. I have no reservoir. I have no pilot. The valve opens and closes through electromagnetic pressure only. It uses electric current only, and they're the highest and fastest reacting valves in the world. Now, you'd say, why do you want to pay 3 times as much per valve and then have 2 valves, which means it's 3 times as much per valve times 2? Well, the whole point here is to put air into the system as quickly as possible. So if you can put high pressure air and fill this faster per unit time, and it happens quicker per unit time, at the hit of a button, it's 80 milliseconds instead of 150 or 200 milliseconds or longer waiting for a pilot to open a second valve because 2 motions take place. You're going to see the results in how quickly things happen, and concurrently you will be able to lower the pressures because the sudden inrush of greater pressure per unit time means these do a lot more work quicker per unit time. So you can bring the forces way down with a properly designed trigger box and not have to worry about possibilities of hurting your performer. It just makes it much safer. It is more expensive. It is more time consuming. It is more detail oriented. But it is part of the theory of why these boxes that you've seen pictures of function 200% better than anything else on the market. And the question gets to be, what do you want to pay for? Like we always say, everybody can drive a car, whether it's a Fiat Punto or if it's a Bugatti. It still has 4 wheels and it rolls. But in our business, where high quality equipment is important considering the tasks we perform with it, wouldn't you rather have a Bugatti that you can drive at idle as opposed to something that will never get you to even the lowest performance level that the high performance would get you at idle? It makes no sense to me, and hence I build that way. So here's a simple diagram. This is how my box is. Your accumulator pressure comes in. There's always a shutoff on your accumulator because you don't want to bring air into the system until you have to. Your accumulator comes in and there's a gauge that's measuring so you can correlate between what the bottle says and what your box is seeing. And as this hose fills, once you open your accumulator, you will see a drop in pressure between the bottle and here because you're going to fill this hose to the same pressure as your accumulator. So once you check that, there's an electronic valve. This is a hand-opened ball valve. This is your ultimate yes or no going hot. Now, this is controlled by electronics. So if you drop your button, it's armed, it's hot, you drop it, it may bounce and trigger it. If you're playing with it, talking to somebody, you don't know how twitchy your button is, you hit it, boom, it's like pulling the trigger on a gun. You fucked up. So this is the last thing you would open in the direction of flow, okay? There's a million rules for how pneumatics are done. Things are open in the direction of flow, hydraulics as well. Things are open in the direction of flow. Everything's designated left to right for flow. You see it all, it's easy to read. Industrial standards for the last 100 years. So I follow all that. Most guys do not. It's just a mixed mosh of magic shit in a box. And if they're really slick, they put a cover plate over it. You've got no way to work on it, no way to fix it, no way to circumvent it if something fucks up. And remember, machinery always fucks up. So here you have your system. Accumulator, air in, gauge, valve, ultimate hard stop, yes or no. You hit the button, it exits to the cylinder. It does work. Cylinder needs to exhaust. This is the only T or direction of airflow change because I can't make it in a square. I could put it parallel and have the ports themselves exhausted. It just works in the box better. It comes down to you can put this valve on either side. This valve is a hard stop just like this valve. If I close this, air will not exhaust. If it's open, it can go to the electronic valve. Just for the sake of interest, you can always, mine are done a little different in that this is your flow control, this is your ball valve, and this is your electronic valve. So you can take this one out of the system here. Doesn't really matter where you put it as long as it stops the airflow to the exhaust. So air will come back from your cylinder, go to the electronic valve, which is just like this valve. So when this is off, this is on. When this is on, this is off. Opposites. And if you don't want to exhaust, you can close it with the ball valve. This is your flow control. It's a metering valve so that you can adjust your exhaust flow more or less. As we mentioned before, you bounce somebody up in the air, it's how fast do they come down. You can control it with this. It's usually a very large valve that flows a high amount, and it's manually operated. Its throttles open and closed, okay? And then you have a silencer on the end because this shit gets really loud at 10, 15, 20 bar. You hear a lot of noise, so put a silencer on the end. So that's your basic two-valve system. Now, you can eliminate all of this here, and you'd have the this is a 2-2 system. 2-2 system. If you were to go to a 3-2, the electronic valve would come out here and go directly to your ball valve at this point. Would be the only way to shut off that flow for sure. And this would be in one direction, it flows here. When you get off it, it flows here. Okay, so that's one valve. You would obviate all these other components, which is fine if that's what you want to do. It's just these valves, 3-2s, cannot flow like 2-2s or direct acting 2-2s. Just a couple of things. I'm not going to beleaguer this. People are going to look at pictures of these, and a lot of people have seen them out there. And there's always been this magic hoodoo voodoo bullshit with people who build these boxes. They aren't hard to understand if you come from an industrial or technology background like I do. Most plants in the world, most industrial processes are controlled by stuff like this. And you can get valves that are electronically controlled on logic controllers that open partially, that can meter air in, meter air out. I mean, they can get very complicated, just kind of like we do with winch work and 3D movements. You could do that with each valve. For our needs, I could complicate it more, but what's the point? Because if it takes a shit, you can't fix it. I just run 2 direct acting monster valves that flow a 14 plus CV, and I leave it at that. I can cram as much air in this as possible in a short period of time and exhaust that air, okay? So you have a very high efficiency, high functioning system. I also, as I stated before, you avoid 90 degrees. Here, the only 90s in my system, if it's the 2.2, is here coming off and here going into this. And I could, if I wanted, put a double port here and use a U-bend. It just doesn't fit in the boxes nicely, and at some point your physical constraints become important. My boxes are fairly large, and I don't put, and I refuse to put accumulators in the box as well, because there's no way you can get them in there without all the plumbing going in umpteen different directions with 90s, etc. By the time you try to, I look at guys' boxes. They've got a piloted valve with a reservoir, with a regulator, and an accumulator in a box, trying to direct air directly to the cylinder, and they wonder why suddenly they're having to turn it up to fucking warp drive to get it to do anything. That's because they've just basically ignored everything about how fluid dynamics works in a system. So that's trigger boxes. I'm not gonna, like I said, I'm not gonna keep beating it to death. You want the best possible flow in the shortest possible time with the most volume you can deliver. As a side note, effects guys know this because they're hucking big, ugly, heavy, dirty shit through the air. Car cannons, they have 2-inch ports with these type of direct acting valves that open up. And the fact is they flow massive amounts of air with massive pressures instantaneously. That's how we cannon cars through the air. That's how these huge ratchets work. There is no substitute for actual size and power. You can always throttle the power down, but you can't make up for it when you don't have it. One thing is to always think about your valves, and yes, they get bigger. The valves I have are 15 kilos a piece. There's 2 of them in a box. So that's 30 kilos right there, just for 2 valves. It's crazy. But they are the fastest. They operate in 80 milliseconds. They have a CV of over 14. That means I can reliably pick people up and set them down where I want with just the push of a button. That's because the flows do not kill it. There's no 90s other than on the exhaust. And since that's a much more, not as violent a function as the pull we want, I can live with it. I've made that choice. I have done some where I've paralleled everything, and it gets even complicated for me. So that's what you're trying to do, folks. And I have a couple anecdotes. There's people in this business that are making equipment, and I've seen it in other countries where they're like, oh, well, you need at least 600 PSI, and that's the average operating pressure. I'm like, no. You should be able to do anything you do at 10 bar. That's the reality. If you can't make it work at 10 bar, then you have problems. And that means you have to look at what's going on with your system. Like I said, the 3-2 directional valves, the piloted, have a whole plumbing world nightmare that goes with them. They use less power, but they also have the air side, leak side, etc. So you got to look at that. Old school, back in the day, 30 years ago, we used to use huge valves, but we used just simple ball valves. Just a big levered open hydraulic ball valve. It's rated at 300 bar, and it has you can read the newspaper through it. And all we did was use small solenoids to open and close those valves. They're loud, they're obnoxious, but nothing flows like a wide open ball valve. So the fact is, when they're closed, they're dead closed, and when they're open, they are 100% flow, and you get some great numbers with those. The downside of that is you do need a reservoir. You do need solenoids controlling small air rams to open and close these mechanically. They're mechanical valves. They work great. They come with a small set of drawbacks. They flow far better than 3-2s. You can make them do anything. You can get a 2-inch ball valve and slam it open and it will be unbelievable. As a side note, many of you might know who Matt Sweeney is through his pulleys that you use and assorted stuff. He used to do car cannons and similar things like that with ball valves. He would bungee them in the open position as hard as that bungee would go, stretch it back and lock it off to a cable cutter or a quick release, so that all you needed to do was trigger that and the valve slammed open minimal milliseconds. and you went from dead stop to wide open 2-inch port in less than a heartbeat. That gets some work happening in a hurry, folks. And it's a simple way to avoid using reservoirs and plumbing, because as he said, too many times the fucking reservoir or the pilot would leak down and you couldn't get it to work. I've used this system on car cannons extensively because it gets rid of one of the areas of failure. And in fact, the last time I did one, I was flipping semi-trucks using car cannons. But it's the same, it's about airflow. I mean, you go, how does a car cannon compare to a Ratchet? Well, it's about airflow in a heartbeat. You know, it's about getting air in. It's how to make all the plumbing efficient and strong as you possibly can to get the most result from this less pressure as you can. So that's what trigger boxes do. You can get into valve theory. There's enough. I mean, if you look online nowadays, it's nice because we used to have to go to books and owner's manuals and pneumatic controller manuals and stuff and look it all up, because we had walls of this stuff in our shops. But now you can just spend all day down the rabbit hole on the internet and learn all about airflow theory. So that's what's available. A trigger box is nothing more than a button-controlled way of delivering air and exhausting air. And it needs the appropriate safeties. It needs the appropriate flow. It needs to be the appropriate volume. And it is an integral part of your system. Remember, this is a system. This is a cylinder. This is an accumulator. This is a push-button control box. All work together to create one thing. So if you've got problems with any part of your system, it becomes the lowest common denominator. And when hot rodding anything, you end up making one thing, breaking the next, fixing that, breaking the next. You know, you track through it all. So you need to really look at how these things work, and you need to make sure that you set your system up together so that it's a system. Remember, it is a mechanical rigging system. Anyway, that's trigger boxes and or push button control boxes. I could get into it for hours on this, and I'm sure you realize that. But there's a reason why we build what we build, and that's because you can't build them any better. And they cost accordingly. But then again, this is what we do to make our living. So, you know, it's kind of like anything else. Do you want, you know, the best car, the best, if you're a professional whatever, do you want the best equipment? Yes, you don't settle for less, unless of course you just want to be able to say you have it. I mean, just having a piece of equipment doesn't mean shit. You can have a car, but you don't have a Bugatti. So it's your choice, you know. It's if you know what you're doing and you know why you're doing it, then you can make your own choices. But the fact is, for a system like this, it's important so that you can be as safe as possible to be able to keep it throttled down. I mean, there's no right person in their mind that keeps turning it up to compress gas in a cylinder, fighting itself. You're fighting itself on every step of the way if you can't do the work. And you try to get the work done as efficiently as possible, and that means make this do what it's got to do as nicely as possible. Okay? So that's trigger boxes, push button control boxes, and we'll do a little wrap up after that. Maybe, we'll see. Because otherwise it gets a little boring, all this theory. Most people don't really care. But I do. Take care.